All right, let's, on example 6, put our new derivative rule into practice, the one that allows us to find the derivative of an inverse function at a particular point. We have, let f of x equal 1/4 x cubed plus x minus 1. And now, if we wanted to find the inverse of this function, it'd be kind of hard, right? You'd have to switch the x and the y, and then when you do, you'd have to try to isolate the y, and you have an implicit equation. It'd be pretty tough to do, especially without, say, the cubic formula. Oh, no. Anyway, so we're going to get around that by doing these two steps. Number one, what is the value of the inverse of 3? And then number two, what's the value of the derivative at that particular point? Okay, so you'll see why that we'll have to find the value of the inverse, particularly at 3 in just a moment. Now, the most common mistake that I witness students doing is that they want to stick that 3 right in there for x, because that's an x value, right? Except it's the x value on the inverse function. It is not the x value in this original function. So think of it like this. On this inverse function, you have the point 3 comma, I don't know, something, right? And then on the original function, those two things need to be switched. So you have the point k comma 3. So this guy is the x value for the inverse, but it's the y value for this original function, which means that we don't stick the 3 in for x, we set it in for f of x, or for y. Let's do that. So I'm going to plug in 3 is equal to 1/4 x cubed plus x minus 1. And we have a cubic equation, which we're going to have to try to solve. So in order to do that, I'm going to first multiply everything by 4, and it's going to get rid of the fraction for me. So let's, with a red color here, multiply by 4. Okay. And then we'll have 12 is equal to x to the third plus 4x minus 4. And then, if it's a cubic equation, polynomials, you always set that thing equal to 0 in order to solve that thing. So x to the third plus 4x, and then minus 16. And now we have to factor this thing. We're going to factor it using the rational root theorem, which takes quotients of, or ratios of, let's see, factors of this 16, which is going to be plus or minus 1, 2, 4, and, well, no, 8 and 16. All right, we got quite a bit. And then we divide those by factors of plus or minus 1, this leading coefficient. So to help you remember which one's supposed to go on top, which one's supposed to go on bottom, if you're going to solve something like this by isolating the x, you would first add or subtract this constant term over, and then you would divide it by the leading coefficient. So it's these factors on top, these factors on the bottom. And you're just going to select something. I'm going to pick something, and then divide it out by synthetic substitution, synthetic division. All right, what do you want to try? Let's try maybe a 1. And then whenever we're listing out our coefficients here, realize we'll have to put a 0 in there for x squared. So 1, 0, 4, and negative 16. Okay. Bring down our 1. 1 times 1 is 1, plus 0 is 1, times 1 is 1. 5, that's going to be not 16. All right, so get rid of those numbers. That did not work. Let's try, how about a 2? Okay, bring down the 1, multiply, 2, add, multiply, add, 8. Uh-oh, got a good feeling about this. 16, 0. Oh my God, this is a mess. 0. There we go. It went in evenly. There's my value. In other words, like I could factor this if I wanted to, but I don't need to. I just have my x value here as 2. X equals 2. In other words, my point here is 2 comma 3. 2 comma 3 on the original one, which means on the inverse, back up here, on the inverse, this is 3 comma 2, which means f inverse of 3 is equal to 2. So there's the first part of that. Why did I need to find that? I need to find that because that, as you'll see, is going to go inside. In order to find the derivative, it's going to go inside here, right? That bit right there. Okay, so we want to find the value of the derivative of the inverse at 3. So we're going to write our little formula down. First of all, f inverse prime at 3 is equal to 1 over, it's a reciprocal slope, right? But it's the reciprocal slope at the y value, not at the x value. And the way that I write that is f inverse of 3. And we just found f inverse of 3. It's equal to 2. So I'm going to plug that in there. 1 over f prime of 2. What that just means is that I need to find the derivative of our function, plug in 2, and then I just take the reciprocal of that. Our function, if I remember correctly, is 1/4, right? 1/4 x cubed plus x minus 1. Plus x minus 1. All right, find its derivative. We get 3/4 x squared plus uno. And we want to plug 2 in here. So f prime of 2 is equal to 3/4 2 squared plus 1. The 2 squared is 4, of course. And that 4 and this 4 are going to cancel out. And I'm left with a 3 plus 1, 4. Which means our derivative is equal to 1/4. So that's the basic technique here, that if we want to find the derivative of the inverse of our function at a particular number, and if I can't easily find its inverse, we're just going to apply our new derivative rule. And in order to do that, you'll need to find the y value inside here. This is the x value. You plug it in here. You plug it in for the y value, and then get the x value from it. Yes? Okay.